Welcome to the high school or secondary school chemistry lessons, brought to you by Donison Dean Research Center, Singapore. This is your instructor, my dean. Listen, learn, and enjoy the process of mastering chemistry. Welcome to the topic on solubility of chemicals. In this topic, we are going to learn about the state symbols of chemicals used in the reactions, such as solids, liquids, gases, and aqueous. We will note that solid state is used for metals, insoluble salts, and ionic compounds, as well as substances that are solids at room temperature. Liquid state symbol is used for substances such as water, molten substances such as molten metals, molten salts, etc., and also for substances that are liquids at room temperature. Gaseous state is of course used for all the gases, such as oxygen, hydrogen, carbon dioxide, ammonia, etc. The fourth state which we use in chemistry is the aqueous state of the substances. Aqueous state is used for chemicals that are soluble in water, such as soluble acids, soluble bases, which are also called the alkalis, and soluble ionic compounds. In fact, this topic is entirely devoted to identifying which substances can be classified as aqueous by knowing the solubility of the chemical compounds. At the end of the lesson, we will look at the summary of the solubility of the ionic substances in the form of a table. Take note that this table should be memorized by the students who wants to excel in chemistry. As we mentioned earlier, the state symbols of the chemicals used in chemical reactions are solids with a short form of S, liquids with a short form of L, gases denoted with a G, and the aqueous state, which is indicated with an AQ after the name of the chemical. We will use solid as the state symbol for metals, insoluble salts, and insoluble ionic compounds. We will use liquid as the state symbol for water and molten substances. All the diatomic and monatomic elements, such as oxygen, hydrogen, nitrogen, chlorine, fluorine, helium, argon, etc., and simple molecular compounds, such as carbon dioxide, nitrogen dioxide, sulfur dioxide, ammonia, hydrogen chloride, water vapor, etc., all uses the state symbol of gases. Aqueous state symbol would be used for compounds that are soluble in water, such as the soluble acids and alkalis, as well as the soluble ionic compounds. As mentioned earlier, the solid state is used as the state symbol for metals, insoluble salts, and ionic compounds. It is also used for substances that are solids at room temperature. Here are some examples of substances that uses the solid as the state symbol. The liquid state is used as the state symbol for pure liquids, such as water, molten substances, such as molten metals in casting process, and molten salts used during electrolysis. Here are some examples of substances that use the liquid as the state symbol. Gaseous state is used for all the gases such as oxygen, nitrogen, hydrogen, chlorine, carbon dioxide, sulfur dioxide, nitrogen dioxide, ammonia, water vapor, hydrogen chloride, etc. Aqueous state is the most important state used in chemistry for chemicals that are soluble in water. These include soluble acids, soluble bases, which are also known as alkalis, as well as for soluble ionic compounds. Aqueous comes from the word aqua, which means water. These compounds can dissolve in water and hence are called aqueous. Knowing solubility of various ionic compounds is very important to be able to apply in the topic on salt-making techniques. One has to know which substance will pass through the filter paper because it is aqueous, and which substance will be retained on the filter paper as it is not soluble. Apart from this, most chemical equations require the candidates to write the state symbol beside the substance. Therefore, mastering the solubility is imperative to doing well in chemistry. Let us look a little deeper into the solubility of the chemicals. Most oxides, hydroxides, and carbonates are insoluble, i.e. cannot dissolve in water, except those of group 1 alkali metal oxides, hydroxides, and carbonates, well as ammonium oxides, hydroxides, and carbonates. For oxides, hydroxides, and carbonates, it is easier to remember what are soluble and remember the rest as insoluble. The soluble compounds are potassium oxide, hydroxide, and carbonate, sodium oxide, hydroxide, and carbonate, lithium oxide, hydroxide, and carbonate, and ammonium oxide, hydroxide, and carbonate. As for the halides, such as fluorides, chlorides, and iodides, most of them are soluble in water, except lead fluoride, chlorides, and iodides, as well as silver fluoride, chlorides, and iodides. How about the sulfates? Most sulfates are soluble in water, except lead sulfate and barium sulfate. Nitrates would be the easiest to remember. Almost all nitrates are soluble in water. This is why, in order to precipitate any salt, i.e. to create any of the insoluble salts, we can use nitrate compound of that salt. For example, barium nitrate solution is soluble in water, and hence can be reacted with sulfuric acid to form the insoluble precipitate of barium sulfate compound. The hydrogen nitrate, or the nitric acid, which is the other product of the reaction, is soluble and therefore can be separated by filtering the products of the reaction. Barium sulfate precipitate would be retained on the filter paper as the residue and can be collected and washed. Another example of precipitation would be the formation of the insoluble lead chloride salt, where soluble lead nitrate solution is mixed with hydrochloric acid to produce it. The other byproduct would be the nitric acid, which can be filtered off and removed from the mixture. We need to know the solubilities in order to write state symbols in chemical equations, for use in salt-making techniques to know which substance to add in excess and filter off, and also in the topic on electrochemistry to identify what products are formed at the anodes and cathodes. We have summarized the solubility of the ionic substances into a single table for quick reference. In writing the state symbols for the chemical reactions, the soluble compounds should be written with a state symbol of AQ after their formula, while the insoluble compounds should be written with a state symbol of S after their formula. We have come to the end of this lesson brought to you by Donaldson Dean Research Center, Singapore. This is your instructor, my Dean, signing off. It has been a great pleasure coaching you. Till we meet again, learn with passion and joy.